How long do you want to be around? Voyager 1, the ancient probe, has done it again. In the boundless, mysterious expanse of interstellar space, this resilient spacecraft has proven that despite every challenge, it still stands as humanity's most reliable outpost. But this time, the stakes were higher than ever before. NASA's engineers had lost contact with Voyager 1. Technical issues had taken their toll once again, and the team had to scramble for a solution. This wasn't the first time. In fact, these kinds of problems have become almost routine for the aging spacecraft. Yet, against all odds, a forgotten piece of technology, something obsolete for decades, would become the key to saving the mission. The backup transmitter, untouched since 1981, fired up just when it was needed most, allowing the space veteran to once again phone home. Imagine this: when it's cold outside, it's easy to just flick a switch and turn on the heating. But out there, in the boundless depths of interstellar space, things are never that simple. Voyager 1 has been journeying through space for nearly 50 years, surviving technical setbacks that would have grounded any other mission. It should have been a routine task turning on one of its heaters. But what happened next sent shockwaves through NASA's operations. On October 16th, after sending the command to activate the heater, the team waited for the response. But 2 days later, they were met with silence. Voyager 1's signal had vanished. They waited in agonizing suspense, unsure of what had gone wrong. The distance was simply too great. The probe had been 24.7 billion kilometers away for years, and it takes 23 hours for a signal to travel that distance. But what exactly happened? Voyager 1, as with any great explorer, comes equipped with an error protection system, a safety net for when things go wrong. This system is designed to conserve power by shutting down non-essential functions. And this time, the heater command triggered the system, despite the spacecraft having enough power to run the heater. The problem? It wasn't just the heater that went offline. The X-band radio transmitter, used to communicate with Earth, was also powered down. As the clock ticked, NASA's experts did what they always do: think outside the box. They knew the risk. The X-band transmitter had been dimmed, and finding the faint signal it left behind would be like searching for a needle in a cosmic haystack. But then, a breakthrough. A faint signal coming from the S-band transmitter. The S-band, the backup, the relic of the 1980s, had been abandoned years ago. Voyager 1 hadn't used it to communicate since 1981, back when the spacecraft was just exploring the far reaches of Saturn. Back then, it was supposed to last just 5 years. But somehow, against all odds, they found it. NASA's engineers were faced with a life or death decision. Should they risk switching the X-band back on, knowing the error protection system could shut it down again? Or should they stick with the fragile S-band signal, even though it was weaker, older, and never designed for this? The decision wasn't easy, but they chose to take the risk because sometimes that's all you can do when you're pushing the boundaries of possibility. On October 24th, their gamble paid off. A stable connection had been re-established. The backup transmitter, which hadn't been used in more than 40 years, had saved the day. But the story doesn't end there. Despite this incredible triumph, it's clear that Voyager 1's journey is coming to an inevitable conclusion. The spacecraft's instruments, once the pride of human engineering, are showing the wear of decades of space travel. The signals grow weaker, the systems falter. The probe is pushing the limits of what was ever expected, but at some point, even the most resilient creations must succumb to the passage of time. NASA's mission was supposed to last just 5 years. Yet Voyager 1 has defied the odds, surviving nearly 10 times longer than anyone could have imagined. How? By carefully managing every ounce of energy, systematically shutting down non-essential instruments, and relying on backup systems like the very S-band transmitter that saved them today. But the power-saving plan has its limits. What happens when something goes wrong, something vital fails? Voyager 1 relies on thrusters, tiny bursts of liquid hydrogen, to orient its antenna and maintain its connection with Earth. These thrusters, once pristine and reliable, have suffered from the ravages of time. The nozzles have clogged. Over the years, deposits have built up in the fuel lines. NASA was forced to switch to a backup set of nozzles long ago, and now in 2018, even the third set, originally intended for course correction, is showing signs of wear. Now, the situation is more critical than ever. The nozzles are clogged, the lines are narrowing. What was once a generous 0.25 mm opening is now just 0.035 mm. It's smaller than a human hair. Every day, the team faces the possibility that these thrusters may fail. And when they do, NASA may lose its connection to the farthest spacecraft ever sent by humanity. To make matters worse, Voyager 1's energy reserves are nearly depleted. Any additional power consumption could mean the loss of a crucial system. So NASA had to make a difficult choice: shut down one of Voyager 1's main heating units to preserve the energy needed for the thrusters. It was a gamble. Could they afford to power down a vital system to save another? The team deliberated for weeks, poring over calculations and simulations. Finally, on August 27th, they made their move. The main heating unit was powered down for an hour, and during that time the nozzles heated up, just enough to allow Voyager 1 to orient itself toward Earth once more. For now. But how much longer can it last? The experts predict that by 2036, Voyager 1 will be beyond reach. The distance will be too great, the technology too old. But the clock is ticking, and with every passing moment, the team at NASA continues to work tirelessly to stretch Voyager 1's life just a little longer. The race against time grows more intense as each year brings the spacecraft further away from Earth. Every signal, every burst of energy sent into the vast, cold void of space is a testament to human ingenuity. But it also reminds us of the fragile nature of this mission and perhaps of life itself. And so, as we witness this final chapter in Voyager 1's journey, we are reminded of the fragility of time and the relentless human spirit that keeps pushing forward, no matter the cost. This spacecraft has sent back more than just data. It has sent back a message of perseverance, of the lengths we will go to in the pursuit of knowledge. It has shown us the very essence of humanity's quest for the unknown and the infinite. But now, as we await the inevitable silence, we must ask: how far will you go to push the boundaries of possibility? How long will you continue the fight, even when the odds are stacked against you? How long will you hold on when the light is dimming and the darkness seems to be closing in? What is your legacy, your lasting impact in this world? Every second that Voyager 1 continues to send signals, it's more than just science. It's a reminder of our own strength, our ability to defy time and space, to reach beyond what we thought was possible. This isn't just a tale of a spacecraft. This is the story of every one of us who dares to dream, to reach, to explore. And just before you go, don't forget to click that subscribe button. The story of Voyager 1 is far from over. Its whispers from the edge of the solar system still echo across time and space. Join us in this extraordinary journey, and stay tuned for the final moments of humanity's most ambitious exploration. We'll see you soon as we continue to chase the stars.